Topic 10-3, domain and range of piecewise functions. I'm going to break down here domain, range, piecewise functions. So you know that domain is appropriate x values. You know range is appropriate y values. And you know function is where x's don't repeat. So the only new vocabulary word is this piecewise. And here is piece. And so it is a graph with a bunch of pieces. So we're going to go through the definitions and then we'll go through some examples. Okay. A relation which is a set of ordered pairs where x value is paired with only one value, y value. In other words, there are no repeating x's. That is the definition of function. A function that is defined by different expressions on various intervals. So different, you could say different pieces. And so this is a piecewise function. So what it is it's going to have a whole bunch of pieces to it. However, it's still going to remain a function. The set of all possible values for the independent or input, and independent is x, input is x. In other words, it's all the x values, including the highest and lowest horizontal limits, and all the values in between. So that is the definition of domain. You have done that before. Now with our Jamboards, we're not going to, and Google Slides, we're not going to have as many issues on your ability to communicate that you know how to do these. And then the set of values for the dependent output, dependent is y, output is y, which results from using the function. In other words, it is the set of all y values, including the highest, lowest vertical limits, and all the values in between, and that is considered range. All real numbers, in other words, the idea that something never ends, and this is called infinity. Okay, before we go any farther, a big concept. Remember in shading that it is a true value, and when there's no shade, that it is not a true value. So if this appears on the graph, this is the value, this isn't the value. This, if there was a vertical line that passed through it, would be a function. This is good, and this is what you're looking for. If you ever find two closed dots on top of each other, that means that's okay and that's okay, which means there's two things vertically different that are okay, and that's not a function. So right there, you know that it's not a function. So a closed dot over an open dot, or vice versa if the closed dot's below it. A closed and an open together vertically is okay. Two closed vertically makes it not a function. Okay, so let's go into this. We already graphed this. You should recognize this as the absolute value. Okay, and in absolute values, remember we can plug two different things in, and get out the same answer. So that's where we're going to have to say, oh, if you plug this in, this is what happens, and if you plug that in, this is what happens. So the absolute function is a famous piecewise function. It has two pieces. Remember that when we plugged this into the x values into the absolute value, it didn't affect the equation. But when we plugged these in, it did. So, when we're looking at domain and range, can you think of any x that cannot be plugged in? Okay, and all x's can be plugged in, so your domain is basically going to go from negative infinity to positive infinity. You could also say all real numbers. Now, this is the symbol for real. It's an R with 2 slashes in it. It's kind of a cursive R. Now the range, I always think of, where doesn't this touch? It doesn't touch. It can never be y is less than 0. So it can be 0. And there's the bracket. And the bracket means an underline. And then infinity with a parentheses. So equated in annotation, this is a closed dot, this is an open dot. The only reason infinity is open dot is the little argument of I'm at infinity plus 1. So this includes the 0. This means there's something on the other side also. Okay, here we go. And notice that it's all real numbers because of the arrowheads. Now we're going to change it just a little bit, and we're going to build our horizontal fences, and our horizontal fences for the domain only go from here to here. So that's -7 and that's 7. And they're closed dots, so I'm going to go here, -7, and here, 7. Okay? This says all-inclusive from -7 all the way to 7. The other way that is okay is you can do the squiggles, remember, and say x is -7 is less than or equal to x is less than or equal to 7, and do it that way, where your inequalities are facing less than or equal to, and you have the squiggles, and that says x can be. And no, I'm not going to accept these backwards this time, that the smaller value is there. And then I'm going to do the range, which means my vertical limit. So the lowest is 0, and it did touch it. And the highest is 7, and it did touch it. That's an acceptable answer. Or you could do y colon 0 is less than y is less than 7. Okay, here we go. Is it a function? Yes, 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 and yes. Okay, what is I'm going to do the domain. So I build this, and the left bound is -8. And it has a closed dot, so I include it. The right bound is 6, but it has an open dot, so I have a parenthesis. So this is color, this is no color. Range. At the bottom, I hit, I don't go continuously. I don't go continuously. So X's, if I pulled this down and I pulled this down, it would make one long chain. But notice there's gaps where the Y's don't hang out. So I'm going to have to list them, and I'm going to have to list them one by one. So this one is at -5, and then we don't have any -4s, but we do have a -3, and we have a -1 and a 1 and a 5 and a 7. And notice this will show me that I have gaps. This is continuous because if I laid these all down, they would be continuous. Here we go. So you know that this is the parent function moved down 2, and that's at -2. So I tend to do arrows means it goes on and on. So the domain means on and on. So I'm going to negative infinity and positive infinity. Infinity always just gets parentheses, not brackets. Range, I can go as low as -2. It did touch -2. And because of the arrows, I can go anywhere up there. So that is infinity, and infinity always has a parenthesis. Here we go. Domain, because of the arrows, is negative infinity to infinity. The range, I can go anywhere from negative to infinity, but the tallest I can go is 6, but I can hit 6, and so that's how that one goes.